Okay, once again, welcome to everyone, and thank you for joining us at today's webinar hosted by CQ University and in conjunction with Livestock Australia. As you know, today's webinar is all about automated livestock phenotyping technologies. We've got a panel of speakers today, and the order of proceedings will be as follows. First of all, we'll have Nick Corbett from CQ University providing an overview of the research to date that's been done through this MDC project and the objectives of the research and some of the highlights so far in terms of aligning automated phenotyping technologies such as walkover weighing and the data gathered through that with objective genetic selection tools like BreedPlan. So Nick will talk on that. He'll be followed by Dr. Lauren O'Connor, also from CQ University, who will be giving you a sneak peek at the technology that sits behind these systems and some of the more recent innovations as we've deployed more units around Australia and around the world, and some of the changes that have been made as a result of producers participating in this project. Thirdly, we've got Swin Hudson, a cattle breeder from Mara in central Queensland here. As a safety precaution, we recorded Swin's talk earlier, but Swin's going to give us an update just in case there was some technology or internet connection issues today, but thankfully he's online to take questions afterwards. Swin will give you an update on how he's been involved in the project and some of the findings, the tips and tools, some of the teething problems, some of the things that have been learned from being an active participant in this research and how that's now shaping up to help him in the longer term. Following the presentations, we'll have a Q&A session with a wider panel, including Professor Dave Swain, who is the developer of the Data Muster system, as well as Rob Newcomb, also from CQ Uni, who's been working hand in hand with producers throughout Queensland in installing and implementing this technology in a commercial breeding environment. So that's the rundown of what's ahead. As I mentioned earlier, all of our participants, other than our panelists here, you are all on mute, but we do want you to participate and be active participants in the session. So if you do have a question, please post it using the Q&A function, and I will endeavour to share those questions with our panelists when their time comes to speak. Finally, just a reminder to you all that this webinar is being recorded, and hopefully that's not going to be an issue for you, but if it is, I'm sorry, but we would like to make this available to as many people as possible. We've had requests come in by email for people who can't make it today but would really love to hear what's on offer. So we will be making the recording available via the Data Muster YouTube channel later this week, hopefully late today or tomorrow. So without further ado, I think we've covered the housekeeping. I'll now hand over to Nick Corbett to deliver the first presentation of the day. Thanks, Nick.
Thanks, Michael. Just let me know if you can't hear me or if this isn't working, but I'll try and get the share screen happening. Is that all right, Michael? Can you see that? Okay, thanks, Michael, and good afternoon all, and thanks for zooming in. In this session, I endeavour to give us some updates on some of the research that we're doing here in Rocky through the Central Queensland Uni, more particularly from my perspective at Belmont Research Station, just north of Rocky. And the following speakers will actually talk on extending the research into the commercial herds. So here at Rocky, we've had our share of challenges with drought, flood, fire, and viruses, but we'll continue to soldier on with the research. Now, this project's been funded by the MLA donor company. The running title, the real title is a bit longer than that, but I've shortened that to a running title of Automating Phenotypes for Genetic Evaluation. So just by way of a bit of background, obviously to genetically improve phenotypes and the traits, we need to measure them. And there's a fair bit of work goes into actual recording the data for genetic evaluation. One of the single most important pieces of information we can measure is date of birth, and generally that, for an accurate date of birth, daily calving rounds are needed. And if you're not doing daily calving rounds, then that's calves are probably tagged at a later date and then mothered up. And at that time, we're also getting information on maternal parentage, another vital source of information we need to record for genetic evaluation purposes. The growth traits, traditionally, they're, I might just add that daily, if you're doing mothering up at a later time, obviously there's there's potential inaccuracies there in recording maternal parentage and guesstimating date of birth on these calves. Growth traits, traditionally, the cattle are brought to the yards and weighed at those specific times, and they're the traits currently analysed by breed plan. So the research we're involved with here was to look at walkover weighing as a data recording hub, and set that up to automate some of these measures for submission into breed plan. And what are the implications of that is in terms of enhanced genetic evaluation and perhaps even higher accuracy for some of the EDVs. I'll just take a bit of time now just to talk about the logistics and the practical delivery of walkover weigh. Also look at how RFIDs are picked up and live weights assigned through the system, and also spend some time talking about some of the reproductive parameters we're looking at trying to automate. So in terms of the practicality of implementing walkover weigh systems, the infrastructure typically consists of panels, a weigh platform, solar panel, battery, antenna, reader, and the telemetry components of a small computer and a modem. It's not walkover weigh as a data recording hub isn't restricted to just those sensors, and there's other sensors could be included, for example, weather stations, moisture and soil moisture, etc. I guess it should be stressed that the system actually, there's implications there just in terms of setting up your walkover weigh system on a watering point. There's things that probably need to come into consideration, including paddock and herd size, the terrain of the paddock, and the existence of multiple watering points. So it's important to realise that the systems are not necessarily plug and play. There's some training needs to be put into so that the cattle become used to the system. In some of the research herds, ideally we've been looking at paddocks with a single watering point and training 440 to 100 head of cattle through the systems. So in the research herds, that's what we've been concentrating on. We've been using more of a passive training system, so that the infrastructure is put up in a stage process, so that the cattle and the cows actually become accustomed to the platforms, the spears, and the panels. Now the last 2 points there about weekly weights and accumulation of the data and reporting on the data will be covered probably more in depth by the next speaker, Lauren. But I just wanted to point out there that the ability of the walkover weigh system, because their cattle are coming to water on a daily basis, it has the ability to pick up 7 weights in a week, and the algorithms we've been using is to actually estimate or calculate a weekly mean using the best 4 weights. And Lauren will talk a bit more on the standard deviations involved in that algorithm. So in terms of tracking live weights, it's fairly straightforward, and the walkover weigh systems do this quite well. The system's not without its glitches in the early stages, and just looking at that graph there on the right, you can see there's a space of about a week there where weights. This is actually a herd of 40 cows, and you can see there in sort of early November, there's a week there where the weights were lost, and that actually occurred where the credit ran out on the SIN code. So these, and despite that, there's some other, we were able to still track those live weights through. Tracking the live weights in the growth, to give growth passes, gives good information on individuals and identifying poor performers. And on a mob basis, it's it's useful for timing of supplementation and also for forecasting turn-off points. I've probably stolen this graph from Lauren, but I've just put it up here quickly to show that some of the research we're doing is to try and compare the variability of a walkover weigh compared with the static weights. The hypothesis is that walkover weigh, because we've got a weekly mean of 4 good points, that there could be advantages in terms of accuracy there, because we're actually averaging the error variance, as opposed to a single static weight, which was taken in the yards, which is likely to be affected by mustering and variability in curfew times prior to the actual recording of the weight. So in terms of deriving some of the reproductive parameters, we can use the growth paths and the RFID sequence of the animals coming through to determine calving date and maternal parentage. Just following the growth path, and that graph there actually shows the growth path of a cow leading up to a calving event, which is signified by the grey line, and you can see a drop in weight there of 60 to 70 odd kilos when the cow calves. So the growth path, we're able to, and some of the earlier work done showed that this is evident in around 80% of the cows in the group, and we're currently looking at tweaking those algorithms to try and improve that percentage, and Lauren might talk a bit more on that in her presentation. We're also able to use the RFID sequence to tell us a bit about behaviour of cattle, and that's certainly the case with maternal parentage. And Don Menzies, in some of his early work, developed a half-weight index, which is essentially just a measure of the number of times that 2 individuals are recorded together, and that showed pretty good accuracy compared to greater than 90% compared to the DNA fingerprinting as a gold standard. Some of the other work we've been looking at is just using RFID sequence. Was to look at the timing of bulls following cows and estrus through the walkover weigh system, and this was confirmed with digital images and activated KMARs, and some of this work it potentially could provide some information on not only post-calving estrus events but also on timing of conception. And the digital images also provide other information. These images don't necessarily need to be digital. You can also probably mount infrared or thermal imaging at the walkover weighs and alter the camera angles. And there's potential there using vision recognition software to actually record other phenotypes and traits such as lactation status, body condition, and parasite infestations, and potentially even scrotal size of young bulls as they come across the system. So just to recap on some of these, on the automation of some of these phenotypes using the walkover weigh. So in terms of birth date and maternal parentage, obviously birth dates, as we said, it's a very important piece of information needed for the calculation of things like days to calving in the cows, gestation length of the cows, and also for weight for age adjustment of the calves' later weights. Maternal parentage is obviously important for estimating herd genetic and non-genetic effects on things like weaning weight. I've put a question mark there on birth weight. Obviously that's a difficult one because in commercial situations the cows aren't going to be tagged until branding, so we're not going to be able to record or assign weights to a non-existing RFID. In the research herds, we're getting the animals actually tagged at birth, so we're able to look at that to getting birth weights. Although we have found that generally speaking, calves don't cross the system until for a couple of weeks after birth. So we've put that one on the back burner. It may be possible to actually extrapolate birth weight from later weights once they've been branded and put RFIDs in, but we'd need to do a bit more work on that. In terms of the 200-day to 600-day weights, brief panel accept walkover weigh weights as the mode of measurement. and likewise for mature cow weight. I've got a question mark there on anestrus interval. Obviously, there's a bit of work required there to use RFID sequence of the bull following the cow into the systems, and essentially to get an anestrus interval, you need to have bulls in there or a teaser animal at least, or a souped up steer to get information. You don't need to have them in there from the start of calving each year. So, and if we're getting accurate birth dates anyway, then the days to calving trait, which is strongly genetically correlated with anestrus interval, that's the one we should be using, because it's obviously currently a breed plan trait anyways. Just a point to make about this, the weight traits. The walkover weigh actually has an advantage in that we can actually measure for each individual their weekly weight at the time they actually turn 400 or 600 days, which would mean that there's no need for a weight adjustment. If that sort of data was prevalent from the systems, then breed plan could look into modelling that trait as a weight trait. Obviously, it could be, and that model might simply look like the models currently used for birth weight and gestationally. There was another point there about the weaning weight or 200-day weight. It's the ability. Another advantage of walkover weigh is that we can actually take that measurement while the calves are still with their mother. And as I mentioned before, the weekly means might be involved with less error because of the averaging of the error variance of those traits. The advantage of having the measurement done while they're still on their dam might do away with the variance or the variability introduced when the animals actually mustered with motorbikes and helicopters brought to the yards and dragged off mum and then weighed at differing curfews prior to the weigh. So there may even be accuracies there in terms of actually determining the milk component of her non-genetic effect on the calf's weights. And I think I'll leave it there. Thanks, Michael, and I'll hand back over to you. I think I need to stop share.
Okay, thank you, Nick. That was excellent, very informative, and good to see where the work is up to in the context of the range of traits that can be recorded via the walkover weigh systems, and in particular the great progress that's being made on date of birth, which is a key highlight of today's discussions. Our next speaker is Lauren O'Connor, who will be discussing some of the aspects around the data flow and the volume of data that goes into making those analyses and what that means for producers. Over to you, Lauren.
All right, can you see my screen and hear me okay? Excellent. Hi everyone, I'm Lauren O'Connor. I'm a research officer with CQ University. I've been working on the Data Master project for about the past 2 years. I've been tasked today to take you under the Data Master bonnet to show how we're using the system to deliver accurate genetic measures. Now, because of time restrictions, I'm only going to be able to talk about our work in relation to walkover weighing and in regard to automated phenotyping, the automatic capture of calving dates, which has been a major area of our research during the past few years. So today we will have a look at some of the hardware and software components of the Data Master system to see how walkover weighing data is collected, processed and analysed, the Data Master digital dashboard and some automated reports to see how information is presented to the end user, the automated capture of calving dates using walkover weighing and some of our recent results, and some of the things that we have planned moving forward. So Data Master hardware. The main hardware component of the Data Master system we call the Data Hub. The photos on the left-hand side of the screen there show data hubs connected to walkover weighing systems at some of the sites that we are working with throughout Queensland and also in Argentina. The photo on the right shows the internals of the Data Hub. The Data Hub contains all of the necessary equipment required to communicate with walkover weighing technology and they are compatible with all types of units regardless of the brand of equipment used. The data hub contains a cellular modem so that in areas where there is some internet connectivity, data can be wirelessly transmitted to from the paddock to our receiving server. We have added recently a USB port to the side of the data hub box so that the data can be downloaded onto a USB device in areas where there is no service. The heart of the data hub is this device here, if you can see my mouse on the screen. This is actually a very small computer called a Raspberry Pi. The Raspberry Pi is incredibly powerful and is the major component that allows the data hub to connect to walkover weighing units and is responsible for the automatic capture of the data. In fact, walkover weighing data is collected and processed on the Raspberry Pi in the paddock before it is transmitted to our server. Some of you may or may not be aware that walkover weighing data is initially collected at a very high resolution on our system at about 15 records per second. The plot on the right side of the screen shows an example of some raw data of a single animal walking across a weigh platform. Roughly points 4 to 19 is the animal stepping onto the platform. Points 21 to 47 is the animal completely on the platform. And then points 47 onwards is the animal stepping off the platform. An algorithm runs on the Raspberry Pi to analyse the raw data in real time and automatically generate a single representative weight ready for transmission. Once the weight data hits our server, it is automatically processed through a series of databases, authentication processes, and automated algorithms. The software structure is quite complex and it looks something like the diagram up the top left of the screen. The system is able to handle large volumes of data very efficiently. Showing below the software diagram are some stats about the data that is currently being managed via the system. Now, one automated algorithm that is particularly important to how we deal with walkover weighing data, and which Nick mentioned earlier, is an algorithm that calculates an animal's weekly average weight. So in most of our analyses, we do not rely on individual walkover weighing weights to estimate cattle live weight, because as you can see on the example on the screen, some individual weights can be rather inaccurate. Instead, each week we run an algorithm to calculate an average weight for each animal for that week. So the algorithm requires a minimum of 4 individual weights that are all within a standard deviation of 25 kilograms. It ignores any weights that are outside of this range. We have tested the algorithm against manually recorded weight data. This is the same graph that Nick showed in his presentation. And we do have confidence in the accuracy of the weekly average weights for estimating cattle live weights, but not individual daily weights. Now, the whole aim of the Data Master system is to produce meaningful information that can be used to make quick and informed decisions. The digital dashboard is one platform that we use to provide such information. Users can log in at any time via an internet website and access basic data about their herd and individual animals. Showing on the screen is the CQERP dashboard, which is a small plot at the back of the university in Rockhampton. This dashboard, as well as the Belmont dashboard, is publicly accessible for anyone to access via the Data Master website, which is shown at the top of the screen. So as you can see, a property map is displayed at the top of the dashboard and shows current stock numbers by paddock. Critical information is displayed in the tabs along the bottom of the page, including an ALMS growth graph, which is derived from the weekly average walkover weighing weights, a breakdown of the numbers of cattle by weight category, also derived from weekly average weights, counts of the numbers of cattle accessing the walkover weighing units on a daily basis, and a table of individual animal data, including the latest crush weights, the latest average walkover weighing weights, and the time since the last walkover weigh records. As well, we have a portal to manage cattle records, including to move paddock, move off property, record death, and change RFID number. A portal to upload data into the system, including walkover weighing data that has been downloaded from the data hub, and a table of today's recorded walkover weighing data. The data displayed on the dashboard is updated every 10 minutes and can be filtered by the inputs on the left-hand panel, including by paddock, by sex, by category or class, and by weight range. The development of the dashboard has been very focused on user needs and wants. We have been working closely with users and responding to their feedback to provide a better product. And because of this, the dashboard is constantly changing and evolving. We have very recently updated the property maps to display the current stock numbers by paddock. And we are also introducing some long-term carrying capacity and stocking rate information to help with grazing management and record keeping. Both of these add-ons we wouldn't have necessarily thought of ourselves without input from users. In addition to the dashboard, we also have a number of reports that can be sent to users, either as alerts or to provide more information than that displayed on the dashboard. All reports have some degree of automation and customization so that they align with different business goals and objectives. Some examples of reports include, but they're certainly not limited to, daily reports that alert users to suspected issues with cattle or hardware, weekly reports that deliver key information, including current stock and market inventory using walkover weighing data, current weight change and any weight change concerns, and management activity reports that summarise the results of crush side data collection such as weaning, preg testing, 200 and 400 day weights, etc. So a major area of research is that we've been using the Data Master system and walkover weighing to automatically capture calving dates. We have developed an algorithm that uses a combination of a cow's average weekly weights throughout the calving season, as well as her individual weight records. The two graphs on the left side of the screen explain somewhat how the algorithm works. So first, the algorithm looks for the greatest negative difference between a cow's weekly weights to identify the most likely week of calving. It then analyses the individual weight data around that period of time for weight losses between 30 and 120 kilograms. The date that demonstrates the greatest weight loss within this range is allocated the calving date. We conducted a trial 2 years ago using 112 cows that calved in 3 paddocks at Belmont. The algorithm accurately predicted 92% of calvings within the correct week of calving, 73% of calvings within 1 day of the observed calving date, and 84% of calvings within 3 days of the observed calving date. Generally, the algorithm will detect calving a day or 2 after a cow has calved, depending on how soon after calving she returns to the walkover weighing unit. It is the cow's first weight record after she calves that demonstrates the post-calving weight loss and signifies to us that a calving event has occurred. Irregular use of the walkover weighing units by cows in the days or weeks around the time of calving can be a major cause of inaccurate calving predictions, and was somewhat apparent in Belmont paddock 17, which yielded slightly poorer results compared to the other 2 paddocks. So this year we had a crack at commercial application using a larger herd at Swin's property, Tremere. There were 291 cows in the walkover weighing paddocks, and unfortunately we were only able to obtain a calving date for 35 of the cows. We encountered many problems during the trial, including a late start to the walkover weighing installations, a load bar calibration problem during the entire first month that caused terrible data to be recorded, and then a major hailstorm which caused quite some disruption to the herd. On a positive note, the algorithm worked really well for the 35 cows and yielded similar results to those that we obtained at Belmont. Similar to Belmont Paddock 17, there was some irregular use of the walkover weighing units that contributed to some inaccurate calving predictions, particularly in the results for the percentage correct within 1 day of the observed calving date. So at present, the key message from us in regard to automatically determining calving dates using walkover weighing is that it takes a team with expertise in walkover weighing, cattle handling, and data science, as well as customized hardware and supporting software. It is certainly not a case of sticking a walkover weighing system out in the paddock and expecting to receive good results. The current algorithm shows great promise, but there are still challenges regarding how to optimise cattle use of walkover weighing and in regard to the transition into commercial application. We are so appreciative of Swin's support in persisting with us and helping us in this regard. So where to from here for us? We will be continuing to develop the data muster hardware and software infrastructure. We have a wonderful technician on our team who is continually finding better and cheaper options for the data hubs. And he also has plans to develop a panel reader to reduce walkover weighing equipment costs. We also have plans to publish some of our algorithms to authenticate our work, and we are also working on a data muster app to help users to collect and upload data into the system. We will be continuing to develop the digital dashboard and reports. We actually have plans to merge the two together and make available some reports that can be automatically generated by the dashboard. We have more work to do in generating stocking rate and paddock utilisation data, and also to maximise the usefulness of the dashboard for users. In terms of automating calving dates, we are currently gearing up to commence another calving trial with Swin. We are working to develop some recommended practices around using walkover weighing to detect calving, and we plan to put these into practice this year, including commencing the walkover weighing installs and cattle training 2 months prior to the start of the calving season, and also meticulously monitoring cattle use of the units throughout the season. Lastly, we will be inviting more collaborators to work with us to test the data muster system, including a consortium of producers in Argentina who are all signed up, but they have been put on hold due to COVID-19. So that's it from me. Thank you, and I will be sticking around to answer questions after Swin's presentation.
Thank you, Lauren. That was really interesting to see how that data gets analysed in a detailed way, and some good insights there into the importance of training animals. We do have a question on the Q&A box from a producer regarding training, and we'll get to that in the panel session straight after our next presentation. So, as mentioned, Swin Hudson, who's the manager of Tremere Pastoral at Mara, has been an active participant in trialling the technologies in a real-world operating environment. Swin's property runs about 1,200 breeders, both for stud and commercial purposes. So this data is really essential for some of his genetic selection decisions. So our next presentation is from Swin Hudson, and I'll ask Nick just to share that video with us now.
We weigh animals, calves at birth, and I found there's a difficulty with weighing the calves of maiden heifers. with some mismothering afterwards. And so I wanted to see whether this system would work in replacing the catching of calves each day, and doing it with this system instead, which means that just to prove that it's working, I've continued to catch the calves, because the systems that I use with the maiden heifers at the moment is to go about every third day, so that most of the calves are well mothered before we catch them. But of course, that gives a lower accuracy, whereas the mature cows, we're going every day and catching the calves right at birth or within 24 hours of birth. I also wanted to get some data that we weren't able to get at this stage, and that is the birth weight of the cow. In other words, the cow's weight after she's had the calf, so that you can get a comparison between that weight and the weight of the cow at weaning, and that way you can work out how much the cow's invested in the calf over and above her ability to forage for that. Those are the two main things we were after. The reason that I got interested in it in the first place was I've seen the walkover weighing systems both up at Belmont Research Station run by CQU, which they've been doing some of this calf mothering work. And that sparked my interest to say, well, geez, this could really work. And the other one was Western Australia, where I've seen the use of it to monitor the quality of the pasture in the paddock. So in other words, they know 6 weeks before the person themselves does, or the manager themselves does, that the paddock has run out of nutritious feed and the cattle are starting to slip. So it's about a 6-week lag that you actually notice it yourself, whereas the walkover weighing system was picking it up immediately. And I like that idea, but that's not the primary reason. The equipment that we used, I had quite a lot of low level panels. They're only 1.4 metres high or 1.3 metres high. So I was able to build the water exclusion pen, or the water enclose the water using panels, which was better than a fence, because we did have a fence on one side still, and that was the weak point. And that lesson learnt there is that we will fully enclose next time with panels, or use sheep fencing, ring lock or hinge joint. So in other words, the calves can't go through in other spots, and even cows will go through barbed wire fences. Rob was really good in explaining what he felt was necessary, and we followed that as closely as we could, and that made it successful. That was the funneling in to the race before you get on the walkover wire, having enough race before the walkover wire, having enough race after the walkover wire, and having enough distance from the end of the race and the water point, so that that seemed to be it's all quite important. What we did find out that we hadn't spoken about beforehand is that old pregnant cows are very fat, and they don't like to squeeze through your normal width crush of 750 mil. And so we had to actually widen the crush system out to 900 mil to accommodate them. So that was an adjustment that we had to make. Of course, it's the walkover wire works on the way in is best, not on the way out. You get more accurate data on the way in, mainly because the calf, when the calf starts to follow the cow, will follow it coming into water, but less likely to follow the cow out from the water. There were times when we'd check in the late in the afternoon, and we had caught quite a number of calves in the water enclosure, and so they had then had to physically push them out again because they do get balked on the spears a bit. The cows get very used to them in the end, and seem quite happy. We were told at the beginning that it should take about 2 weeks for them to settle in using the spears and the crush system, and that's true to a certain level of true, but not complete. There are some animals that take longer, and there is a lot of stress on us because we feel that we're putting the cattle in a position of, because we'd started with some fairly hot weather, of perishing them a bit, and but in the end it worked, and it worked so well that even if you opened the side of the yard up to get the vehicles in there to do maintenance, the cattle wouldn't use that gap. They would still walk past that gap around to the crush and then come in over the walkover wire. So that's when their habit really starts to develop. So is in a time frame, I suspect it possibly will take a month really to say that yes, they are using it properly, and then of course you need a month before they start calving. If you want that calf data, whatever calf data you want, you need a month beforehand, because if you need 4 correct weights per week, not every week do you get that. There's, calf comes on before, or a second cow comes on before the first cow stepped off, all those sorts of things, and that's to do with lengths of crush, of weigh beam. If the weigh beam is too long, or if the weigh beam is too short, then that can cause things. But that 2 to 2.4 metres seems to be the sweet spot. I think it will work more smoothly. I still don't think I know everything about it. I think that there's still things that we have to learn. The real difficulty is moving cattle from one water point to another water point, or a rainfall event, or just expanding the size of the paddock. There's very little. Any change will have an impact on collecting the data. So if the scenario is that you can have them in the one paddock for the 2 months before they start calving until a month after they finish calving, then that would be the perfect situation. And if it didn't rain large amounts to interrupt them, I think that, and then I also think that there's a herd size issue, and that's in that they are, as the herd increases in size, the herd behaves slightly differently. When it's a small herd of, say, 50 head, they are one compact group, and they will stay as one compact group with just a few head that will wander off from that group, and that group will come into water together and they will go out. And then once it gets bigger than that, then they start to split up into 2 to 3 groups. And those 2 to 3 groups are normally dry cows, cows that have just had a calf, and cows that have had a calf that's a few weeks old. And so you end up with these 3 groups. Once you get over 200 head, then you get about 6 groups. And not only that, they then will take the opportunity to look for different waters, so watering points, because they don't all want to come to the same watering point. Well, the data that was gathered, it basically picked up the birth date a day after the actual birth date for most of the animals. There's a case of a 2 to 3 day variation with some of the animals, but then when we explore that data, we find that that's animals that we've mothered the calf, and the calf has already been 2 to 3 days of age, and so we have guessed the age of that calf, because we've picked up the calf and we said, right, it wasn't born last night because it doesn't have a bloody umbilical cord. So therefore it's older, it's well dried, so therefore it's 2 days of age. It's missing, it's already fallen off, so therefore it's 3 days of age. But all of these, so the two coming together basically telling me that we're overestimating the age of the calf on the calves that we're catching, and possibly the system is more accurate with the actual calf date of birth, so long as you take that calf date of birth as being the day before the system says it is, and which seems to be the most accurate point of the things. There are some animals where it's quite a long way out, 5 to 9 days, but that was it's only 5% of the animals. And then, of course, the cow also throws the curveball in by some cows coming into water on the same day that they calve, and some cows waiting 2 to 3 days before they come back into water after they've had a calf. Well, I think that this will solve the problem of my handling calves of heifers, first calf heifers, and also handling and what I would like to then do is to develop it on and use auto drafting and pull the calves off, say once a week, once the ones that start coming in following their mothers, and any that are in there that are not tagged, well, it should be able to pull off the ones that aren't tagged. I can then tag them at a week of age and slowly and develop the data up that way. So I do feel that that's into the future. Right at the moment, I still want to. I've got to prove to myself that this is going to work. At the moment, it's looking as though it will, and I suspect from what we've got that it will work. All the extra information that I get from how much weight loss I'm getting on cows after calving would then bring in the management of whether I need to supplement after calving or not supplement after calving. So it's going to tell me those sorts of things. And so, yes, there'd be a change there. There'd be an increase in the amount of data and the fact that I end up with a birth weight of cow, and to go with its weaning weight of cow, because right at the moment I'm only collecting the weaning weight of cow each year. You're about to weed out the ones that are better mothers and better at converting food to feed both the calf and itself. So in other words, because you get cows that feed themselves, cows that feed their calves, and cows that feed both. Thank you for listening to my experience with this system, and I wish everybody success that's interested in attempting to do this.
Okay. Thank you, Swin, for sharing that experience and some of the successes that you've had. Some interesting questions have been coming in, and I think Lauren and Swin touched on one of the key ones there about the process for training animals in order to get the best data out of that. I might ask Rob Newcomb, who's working with the data muster team at CQ University and working with producers day in, day out, to briefly speak to that issue of how to best train animals.
Thanks, Michael. My name's Rob Newcomb. I'm a research worker with CQU. I'm also a cattle producer, and so that's probably some of my role, where being able to work with cattle producers. So therefore, as Swin said there earlier, when we actually, I find that the demographic working with a breeder herd is probably slightly different to a backgrounder herd, whereby you've got these calves involved. So therefore, it's as Swin covered on it there before, it's very important to have these animals trained. And like as Swin said, I think that people probably need to sort of manage their expectations of what they really want to do with walkover weigh. And so therefore the training of the animals is probably the utmost. And during the training of the animals, hopefully we get the glitches, any glitches with technology right where we're going. In saying that, the more passive approach that we can have towards training the animals, that it's got to be their idea. And the animals that learn that way tend to be very good users of the system and tend to walk over it a lot easier. And as Swin described there before, we lengthened the races out. That's because more extensive situations, the animals are appreciative of longer races, and they'll tend to walk on, and it'll slow the animals down a lot more to get more of that nose to tail entrance onto the weigh bridge. That cover that there for you, Michael?
Yeah, that's good. Thank you, Rob. Sorry, I'm just joining Nick at his desk now. My computer has lost connection, so I'll join Nick in his office while we host the rest of the panel session. We're adapting on the fly in this age of agile economics. So yes, that's it. So one question that did come in, Rob and Swin might like to talk to this. In your experience, how long does it take the cattle to get used to the system, and can they damage it during that training process? That question came from Maria Witten. So if either of you would like to talk to that question.
You go, Swin.
Yeah, okay. Okay, so there was some small damage during the training process. Spears are the thing that takes the brunt of this. Cows that are wanting to return the way they came. One of the things that Rob suggested right at the beginning was that the exit be away from the entrance, not coming up beside it, and that, I suspect, probably reduced their problems. This was very nice having this experience. It reduced errors that I would have made. And the process it took 2 weeks, and we had most of them trained, but there was some holdouts that were a bit difficult. There was one other point that my wife just brought up with me, and that's enclosure size. The original enclosure that we made was quite large, and we didn't have any difficulties with that. When we moved them to another large enclosure, but then found animals going back to the original one, and we had to form a small enclosure, and the bulls took up battle stations inside the enclosure and excluded all other bulls, and even some cows were intimidated from coming in. So those are the sort of things that were, and those sort of, 2 bulls fighting in a small enclosure causes some damage too, but that was later on after they'd been trained. So that's my own thing on this.
I personally found that most of the damage was done by the operator because they felt that the animals weren't, sorry Swin, not in your situation, but if people felt that the animals weren't using it, and so they mustered the mob and they'd get behind them and push them but that's fine. But that's probably where you can get a little bit of a misalignment of your panels and that sort of thing happening. It's as you can picture, but more passively that they do it, and if you can actually hold the mob behind it, if you have to do that sort of thing. But it's basically the more passive you can using it, where you just open the panels and allow them to come through, or have, as in Swin's case, we had a very long race, and we put it on a cattle pad and coming into the water and at the right aspect as far as the sun light aspects to it. So then there was no balking factors. And another thing that basically, if you don't have any distractions for the calves to go off and have a little crash, no Swin, he had a borrow pit there where he got some gravel to put around the trough and produced this daycare pen for these potties, and there's about 40 calves would be out there playing in the pit rather than sort of following their mother through, and so mum would get a bit anxious, with it in and out. So there's all those little things that you people as cattle people understand, so there's just those little things you just do when you manage your expectations of what we want or thing. But basically, it is about getting good data, and as Swin said there before, that's you just got to narrow down those numbers of abnormalities so you can get that good data.
Okay, thanks for all this, Swin. Another question has come in from Andrew Bell I'm assuming Andrew's from South Australia. He's given us two questions. Firstly, is there any interest in doing walkover weighing in South Australia? And I might answer that one, Andrew. Look, as Lauren and others have touched on, we've got sites in Argentina, so there's no reason why we can't have sites in South Australia. We're always open and very interested to hear from producers who are keen to participate and host the commercial trial sites. And the best way to get in contact is to email info@datamuster.net.au. That's info@datamuster.net.au. So that's the easy question. I might direct this one to Lauren. Andrew's also mentioned that in his experience that some cows don't go to water for up to 48 hours after calving. And might get you just to touch on how is that factored into the algorithm and making sure that we get an accurate date of birth provided back to the producer.
Yeah, for sure. So we've found similar cases at both Belmont and Tremere. It does vary, and it's often in relation to the cow's drinking behaviour in general. So some cows that are used to coming into water religiously every day, they will continue to after calving. Some cows that water less regularly are likely to come in less regularly after they've calved. But certainly there's variation in our results between the predicted calving date being on the day of calving or the next day of calving and up to 2 to 3 days after calving. The way that the algorithm works is it assigns the calving date as the cow's first weight record after calving. With Swin's, he particularly noted that was 1 or 2 days after his prediction. So this year we actually provided a range in the data. So we're providing the calving date, but we are also providing the date of the cow's last weight record, where she recorded her heavier pre-calving weight. So we can now provide a window within which she has calved. That can be 24 hours. It can be up to 3, 4, 5 days. So that's sort of the closest that we're going to be able to get at the moment, I think. This year at Swins, I did mention that we are going to be monitoring the cow use of the units absolutely meticulously to ensure that they are using the systems regularly so we can try and tighten up that calving window.
Thanks, Lauren. I'm conscious that we've clicked over the 1 p.m. mark, so we do have 3 more questions if that's okay. First one, picking up on that point around the training of the animals and getting that good throughput of data and the different behaviours of animals. Just wondering whether the panel would like to comment on what their recommendation is. How much time pre-calving do you need those animals going through the system to get maximum benefit from the data? Rob or Lauren, do you want to comment on that one?
I can comment from the data perspective. So the algorithm relies on at least having 1 average weekly weight for the cow before she calves, because the algorithm looks for the weight differences in her weekly weights. So we need at least 1. 3 to 4 is ideal, so we can get a really lovely pre-calving weight pattern, and then we should see a lovely drop when she calves. And then we also need a couple of weights after she calves as well, a couple of weekly weights. Sometimes the calving weight doesn't show up in the exact week that she calves, but it shows up in the next week. So our recommendations are to have at least 3 pre-calving weekly weights per cow and 3 post-calving weekly weights per cow. In terms of training the cattle and having the cattle on the units long enough to provide that information depends on the cattle and the setup, and probably more related to Rob and Swin to answer.
Yeah, Swin, I was going to ask you your experience in that, because particularly when you've got a, you know, that probably that 6-week window, 3 before, 3 after, in terms of your paddock management and allocation, what are your plans, having been through this process already once?
Well, this year we're actually geared up to start at the right time instead of being on the back foot. So that's good. We're putting them into training this coming week. Well, actually we'll start at the end of this week. And then so that hopefully we will get, and they shouldn't, the first calf should be the 1st or 2nd week of July. So we're pushing a little bit on this, but I can blame coronavirus a little bit on that. Let's put us back about 2 weeks on this process. So we should be right with that, and that's the plan with that. Hopefully this time we won't have the hailstorm, which meant that we had to move cattle or find more grass further away, which created those things. I can't do anything about rain. Rain is going to come and go. The paddocks that we're trying to use within the system don't have creeks in them or gullies in them to retain water from the rain, but just has to have a little dip in the ground and they'll get a drink from that, lick of the grass, whatever that is. I suspect the heavy dew might have an impact, but so that's the sort of things that we're looking to do. This other thing too is I'm trying to push the system. There was 290 this last time. We're going to go a bit more than 300, about 320 cows measured. So we'll stress the system a bit because we've just got to find where it might break down and then find solutions for that. And because we go out every day or every 2nd to 3rd day to catch these calves and weigh them, and we're going to be doing that again this year to prove the process, so that's the whole, it's the combined bits that's going to hopefully make this work for us.
Thank you, Swin. Another question has come in through the chat, the Q&A function. we have a question about the opportunity to paint mark cattle that you've identified as of interest. Now, I'm not sure whether the question is referring to, paint marking in the paddock, or whether it's about, marking them as of interest in the data master software system, being able to say, well, that one's behaving differently. How do we investigate that one individual animal? And I think that's definitely possible on the software side. Is that right, Lauren?
Yeah, it is for sure. So the main one, I suppose, that we work with is a daily report that will identify any animals that have not accessed the walkover weighing unit for 3 days because water points are enclosed and the only access is through the walkover weighing unit, unless there is surface water or other waters available in the paddock. We assume that if they haven't accessed the system, that they haven't drunk. So 3 days is our alert criteria, and that email will come out once a day if any animals are identified. So I'm not sure if that answers the question, but
you can definitely interrogate down to individual animal level in the system and understand their weights at any particular point of time. If you know of an ID number of interest, you can track individual animals. Dave? Yep.
Yeah, I just might add to that one. So the system can control an auto drafter at the moment, so we're able to obviously select animals on their RFIDs as they come across, and it certainly would be possible to use that RFID and connect that up to some sort of spray marker if you wanted to mark particular cows or calves that, for whatever reason, you wanted to identify in the paddock or in the yards. It would be possible to do that if there was a need for it. So yeah, it can be done.
Okay, another question for you, Dave, might be a good note to end on. We have a question from Thomas Williams regarding the future of Data Master as a software platform and whether it's being developed for commercial purposes. He makes the right assumption that all the hardware, the equipment appears simple to source and work with. So that's very true. But Dave, you might want to just touch on what the future holds in terms of access to the software and the types of hardware that are recommended to producers when they are considering installing.
Yeah, certainly. We try to make the system as accessible as possible, and wherever possible, we've tried to enable it to be connected up to as many providers of the peripheral components like RFID readers, weigh bars, etc. Again, we try to be fairly open about the way the algorithms are developed, although I think Lauren did a great job of providing a really good summary. There's quite a lot of work that goes on in the background to make those happen. I suppose we're at that challenging point where, as a university, we can take it so far to really scale up and provide the necessary level of support for all of that technology. We may require us to partner with some commercial entities to I guess bring all of that to the market so that more people can access it. I think what's really critical here is at the basic level, getting a weight of an animal on a walkover weigh system is relatively easy to do, all of those components, but driving the real value through the detailed analysis of long-term data sets, connecting up things like different paddock configurations, understanding breed differences, etc., requires quite a lot of extra work and aggregation. So I think in terms of the hardware, I think that will be relatively easy, relatively cost effective. I think the real value proposition and the real opportunity is for continued development of those algorithms so that we can continue to refine the system and drive a lot more information, not just for genetic improvement programs, but for management and even things like marketing cattle and identifying. So I think that breadth of opportunity is where there will require quite a lot more work, and we're very focused on facilitating that.
Thank you, Dave. As I mentioned earlier, if you are interested in either being a producer hosting a trial, or just finding out a little bit more about how the system works. More information is online at datamuster.net.au, including that live feed of data from Belmont Research Station, so you can get in, have a play, interrogate it, get a feel for how the system works, and register your interest through that platform, datamuster.net.au. Thank you very much, and a special thanks to our project sponsors at MLA Donor Company. Thank you to Swin and our other presenters today. Thanks, everybody.